Well, hey there, it's that coding guy here, breaking it down, making it accessible. Today we're going to talk about classes. Now, Java is an object-oriented programming language, and classes are the fundamental building block of Java's object-oriented nature. So we'll dig into that today, and even though it's such a foundational building block, or maybe because it is such a foundational building block, I find it's a place where people often will start getting confused and not be sure how to work with classes and things like that. So I really want to break that down today. I've got a main class here with a main method. This is going to serve as our workbench. But before we do some of the cool stuff here, we're going to have to go ahead and define a new class. So I'm going to stick with the library theme here, and I'm going to right-click my package and create a new Java class. I'm going to call it book. Now, we often tell folks that are learning that classes are used to define and model objects we know about in the real world. So I'll stick with book here. I think it's something that most people are familiar with. And the thing about classes are that they contain, at the end of the day, really two things. One is they contain data. Two is they contain behavior. And we're really going to focus on the data part of that first. So to get started, we will think about the types of information that we'll need to store in a book or about a book. And I think one of the fundamental things we might want to know about a book is the title of the book. To define these properties, we'll have to think about data types, right? If we ever wanted to create a new variable, we have to think about what data type we want for that variable. So as far as the data type for an author or a title go, we would want to use string. So we'll use string title, and we're not actually going to give it a value right now. Okay, we're not thinking about any one book in particular. We're thinking about all books that we want to track. So let's start off with that for now. And what we can do is come over to our main method and use our book, right? And this is one of the points of confusion. We're defining a book here, the class itself, the class definition, but to actually create a new book object, we need to do that somewhere else, okay? So we're here in the main method, and we're going to declare a new book just like we declare a new variable of any type, right? We start off with the data type. And for the most part, the name of the class and a class and a data type are synonymous, because one way of thinking about classes are they're just custom data types. So the data type of our class is book, and I'll call this my book for now. And we'll just declare a book. Right? If we did this with another thing like string my string, the value of these start off as null. Okay? So for objects, if we haven't actually initialized them to a value, their value is null. And to prove that, which is null, if you're not familiar with it, it's a keyword in Java. That's why it's orange here. And it really means the absence of a value. And so if we print out, using our little macro here, sout, for system out, we print out the value of my book. It's actually saying, hey, this may not have been initialized. So to get that to stop complaining, we could just initialize this to the value null. And if we print this out, we get null, as we expect. So let's actually use our class to create a new instance of a book. To do that, we're going to have to use something called a constructor and the keyword new. So when we want to instantiate a new object from our class, we use the new keyword, we use the name of the class again, and then we use an open and close paren. So what we're doing is we're calling a special method that belongs to our book class, and it's called a constructor. Now, we don't actually see that over here. It's invisible. It hangs out on a class by default. And so we can take a look at what it looks like by actually defining it. And that is so. This is part of the behavior of our class. It's actually a method definition. And we can tell that it's a constructor because this method lives in the class book, and the name of the method itself is the name of the class. So that's how you can tell that this is a constructor. And so what it will do for us now, if we print out my book again, we basically get this string of letters and numbers. This is a memory address, which is kind of perplexing and frustrating for folks who are new to this. Like, what is this thing? That's not anything I recognize. So it's really referencing a location in memory. So one way to get around this is to actually define a method that prints out the title. So there's a method called toString. And if we right click inside our class and we go to generate, we can pick toString here from the list. It automatically has my title property highlighted already, and I'm just going to hit OK. So what this method does, we can see here that it returns the stuff in green as a string. So it's saying, hey, there's this book. It has an open curly, which is commonly thought of as an object in programming. And then we have, hey, by the way, the title is equal to whatever the title of our book is. And then it has a close paren. So if we just rerun this method again, Java's going to use our toString method. So we can see now that the book has a title of null. And null is the default value for a string. It's also the default value of any object that hasn't been initialized to a value is null. So that's why we're seeing that there. So how do we make this my book variable actually have a title? Well, what we could do is my book.title is equal to the color purple. And if we print this out again, we will see that title is equal to color purple. However, this is actually an anti-pattern in Java and some other strongly typed languages, where we're going directly to my book and we're referencing one of its properties by using the dot here, right? My book dot title means the title property of this book. All right, the title property of the book. But as programmers, we kind of like to be sticklers. We want to make people use our classes the way we want to. We don't want to allow just anyone to willy-nilly reference and change the title of the book. So what we'll do typically is use something called getter and a setter. And these are part of the behavior of a class. And we could type this out ourselves, but IntelliJ is great. It's got this way to generate getter and setter. And if we do that, we now have a couple of methods defined, right? These are just methods or functions that we've talked about previously. They've got the access modifier. They've got the data type that they return. They've got the name of the method, and they've got parameters that they take. So getters, typically, they don't take any parameters. They just return the value of the property. And setters are a little method. They don't actually return anything. They take the value and assign it to the property. And if we go ahead and make this private, what we've done now is say, hey, actually, let's take a look at it first over here in main. It's now red over here, okay? So it says title has private access in com.library.book. It's not allowing me to set the title by doing mybook.title. It's going to force me to use the setter. IntelliJ being helpful here. So now I've got to use the setter. I have no other choice if I want to change one of the properties of that book. And this is the way we want it to be. That forces anybody to use our set method. Why? Like, all it does is this. So what's the point? Well, for a simple property like this, we don't need anything more fancy. But if there was more complex business logic behind how we set a title or what we might want to set a title to, we would force other people to come in and basically whatever they supply has to go through this method and any logic and rules that we set up. So that is the value of using getters and setters. And it's just the way things are for the most part. It's a big part of Java to have these getters and setters like that. So we've got one property, and we've got our book here, and when we print it out, we get the color purple. But we can create as many books as we want to, right? And actually, maybe I'll rename this to be a better named variable, right? Good naming conventions lead to self-documenting code, make things much more understandable and readable for ourselves and others. We can also have book, the Dark Tower equals new book. And we could use the setter to set the title of this to the Dark Tower. And if we wanted to print that out as well, then cool. So again, we're using the book class as a blueprint. The class itself is not an object. We're creating objects that are based on that class. They're based on that blueprint. And each one of these is an instance in memory of that class, which is not actually an instance in memory. So we can create more properties here. You know, we could further define our class to have an author, and we could have an ISBN number, you know, all types of things that we want to know about each book. And you know, different applications are going to have different ideas of what each object is. You could imagine that if we're just building a library system for a kid's library, you know, maybe books would have a certain set of properties. But if we were defining the book class for the Library of Congress or a research institution or something like that, maybe we would have more or less properties and properties of different types for those different applications. And, you know, if all we're doing is a children's reading program, you know, we wouldn't have to go too in depth, but so those will differ there. So that's the basics about classes. I think we could probably talk about one additional thing that trips people up before we close today, and that is additional constructors. So we have a default no argument constructor here. It doesn't take any parameters. It doesn't take any arguments. But we could define one that does take additional arguments. So if we want to do that, actually the easiest way again is to rely on our IDE here and have it generate a constructor for us. And I can select all of those. I just held Shift real quick to hold Shift and click down here to select all of those. And hit OK. And this creates a brand new constructor for us. And again, this is very much like a setter, okay? We're taking in several parameters, and this method is setting those parameters to the properties that we have. And so instead of doing the darktower.set, oops, I forgot to create the additional getters and setters for the other properties. No worries there. I can just generate, once again, getter and setter, and it's giving me the options for those that we don't have getters and setters for already. And what I can do is delete this toString method and have it regenerate the toString with those additional properties as well, right? And I always recommend that to folks. Don't come in here and edit your getters and setters directly. Just delete them, blow them away, and regenerate them, because the opportunity for you to make a small mistake is pretty high, and I prefer just letting my IDE take care of that for me, rather than the possibility of introducing a human error, because if there's a chance, I'll make one, I can tell you that much. So the darktower.set, now I have access to these getters and setters we just created. Stephen King and the darktower.set ISBN. don't remember the format for those off the top of my head, so I'm making stuff up as I go here. So now when I print out the color purple and the dark tower, I can see the author of the color purple and the ISBN are null because I didn't actually set them up here. And remember we said that the default value of strings and other objects that have not been initialized to a value, their value is null. And then the dark tower one shows up over here because we defined that here. But we could make use of the constructor that we just created too, that additional constructor that takes arguments. So let's do that. I'll do book dark tower constructor equals new book. Oops. And I just open and close these parens, and right now it's telling me, all right, string title right here, string author, string ISBN. That's because we defined this constructor here. And it takes title as the first parameter, like order matters here, okay? Title is the first, author is the second, ISBN is the third. And that's exactly what my IntelliSense was telling me here. So we'll start off with the dark tower as the title. We'll separate that with a comma to go into the author now, Stephen King. And then and right now that just popped in from IntelliSense. It actually recognized, hey, you're using that constructor. I'll be helpful. The title is the dark tower. The author is Stephen King. And then the ISBN, I'll just copy here. Throw in some quotes. ISBN. All right. So what we did, I'll zoom this out a little bit, is use the constructor instead of doing all of this on 4 lines because we separated the declaration and instantiation of this book and then use the setters here. This is just shorthand, okay? This is the main part of what a constructor is for folks just learning. It's a convenience method. It's just a convenient way, instead of saying set title, set author, set ISBN, we just do it all in one line. All right. So that's the main value of a constructor for beginners. In the future, what constructors do is they're actually a workbench. And I like to say we can do whatever we want. It's just a place to perform logic. If we had some business rules that said, hey, titles must conform to this rule set, you know, maybe they can't begin with a number or something, which probably isn't true for a book title. Or, you know, we don't want to have any crazy symbols inside author. Like we would never want to allow a % sign inside of the author name. We could write some code here that does some of that validation so that if anyone actually tried to construct and use our constructor to make a book that had something that wasn't valid, we could throw an exception and do some crazy stuff there. So that's the other part of the value of a constructor. Again, it's kind of like the getter or the setter. We're making people use our code the way we want. And so we could enforce people to use this constructor if that's the only constructor that we wanted to provide. They would have to use it. And therefore, their stuff would have to fit whatever our logic says. So convenience and enforcement are the main things about constructors. And I think that will do us here for today. I would recommend creating some classes for common objects that you like to think about and practice defining those in one place, and then bring those into your main class, instantiate instances of those classes, and fool around with printing them out. Make sure that you've got a no argument constructor. Make sure that you've got getters and setters and you're using those appropriately. It may not make a lot of sense right now. Unfortunately, it's just the way it is for Java, and you will be expected to have those. And it's best practice to always provide a toString and always to provide your getters and setters and things like that. So definitely always have those as an item of professionalism on all the things that you do. They will be expected, and there are some other things that classes usually have too, but for simplicity, we're going to leave those out of this discussion now. So that's all. Hope this helps your basic understanding of getting some classes off the ground. Cheers.